and throw up some. I'm going to throw up a spotlight for you. Oh, you're good. You're going
Okay.
good. Sharing your screen. You're doing great.
All righty. And okay, I didn't mean to preempt them.
No, you're good.
All right, cool. I'll also share this link with everybody, so you'll have everything that I'm sharing today. I learned how to do story maps through working with Globe, and I just kind of fell in love with it as a presentation mode as well. So I'm doing this today. I'm using a story map. And part of what I love about it is it's one link to rule them all. So should you have other things you're interested in and I don't touch upon it, I'll be more than happy to add it to my talk here. One thing, Grace, I can't see the chat, so I will try to stop from time to time. And if you'll let me know if there's any questions, I would appreciate that.
Definitely will, Dorian. And just wanted to let everyone know what this webinar is about real quick, just in case you're coming in. So this is part of the Year of Climate and Carbon. And when we have the lovely Dr. Dorian Janney joining us today to talk about the Global Precipitation Measurement Mission, which is a NASA satellite mission that's been going on now for 10 years, if I'm not mistaken. And she'll be talking a lot about this particular satellite mission and how it relates to Globe and Globe data. And so if there's any questions at all about the mission or Globe data, please put them into the chat, and Dorian and I will work to answer those questions as best as we can. But thank you all for being here. And now I will be quiet and pass it off to Dorian. So thank you for everything, Dorian.
My pleasure, truly my pleasure. And in full disclaimer, I'm actually Ms. Dorian Janney, not Dr. Dorian Janney, but sounds pretty nice. I appreciate that. Okay, so here's the things I'm going to talk about today. I'm going to talk a little bit about climate change, but more looking at climate change and then helping us to tie in where precipitation and where even having NASA satellites, which are measuring various environmental parameters, where do those fit into our study of climate change? And then I'm going to be looking at, with Globe, we're collecting data from the ground, which it's really cool because you can compare it to certain satellite data that we have, and I'm going to be showing you how. But those the data that we're collecting from the ground is absolutely vital, because even though we're collecting some data from space, we aren't always getting it right. And it's always important to have as much data as is possible to better understand things that are happening. So then I'm going to be looking at what I called IVSS data. And that's basically data that one might want to consider using as a part of their International Virtual Science Symposium work. So what you're looking at right now on the screen is an animation that was done a few years ago that's showing some of the key drivers of climate change. I really like this animation because it's taken us all the way back to, say, the 1800s, and being able to look at various sources. Scientists have been able to track the impact of, as you look over on the right, you can see observations. So that's data that has been gathered. And then natural drivers. If we were only looking at the natural drivers that we know exist with our climate, even before there were people, our climate changed. However, we are able to isolate and to see the impact that has occurred from what we call human drivers. And over here, we're looking and we're seeing that we're looking at temperature in different parts of our planet. So here we're looking at it mid-stratosphere, kind of coming down through the clouds. Lower stratosphere, this is our surface temperature. This is the one that kind of impacts us most directly. And then we're down here looking at ocean content. So I started off using this to show that we have an awful lot of data, and I know I'm preaching to the choir here, that lets us know that our home planet is changing in a lot of ways. And it's really, really important to be able to document those ways and to collect data, and then to try to look at that data and a lot of different data sets and get a sense of what story that data is telling. I'm going to start us off kind of framing the situation and showing you a video that is about how we use
the reason that we as humans care about climate change is that it affects not just the temperature, but a whole bunch of other things that we care about. It affects soil moisture, which in turn affects our ability to grow the things that we eat. It affects cloud cover. It affects rainfall patterns. It increases drought risk in some regions and decreases it in other regions.
Understanding our changing climate on a planet with incredibly complex and interconnected systems is a massive scientific undertaking. And climate scientists like Kate Marvel are using the data collected by satellites from around the world to improve the power of climate models. If we want to make better decisions about where we live, understand the changing impacts of hurricanes, or improve predictions of fire seasons, we need evolving climate models.
We don't have any observations from the year 2050, from the year 2100, but we can use our best knowledge of physics and chemistry and how the Earth system works in order to look at the impact of different emissions trajectories, different policy scenarios.
Climate models provide a view into our future, from our globe to our own communities.
As models advance, as they're tasked with predicting the nature of the weather and the clouds over smaller and smaller scales, they're being asked tougher questions like, well, what kind of clouds are happening over those small scales and how often and how heavily are they raining?
We expect roughly on really, really large scales, climate change is making wet regions wetter and dry regions drier. But at the same time, it's shifting the circulation of the atmosphere. So the locations on a very, very large scale where those wet and dry regions are changing.
Climate models are composed of lots of different calculations on the different behaviors of our atmosphere, our land, and our oceans. To accurately represent the natural world, they need massive amounts of satellite data over decades from NASA's Earth observation fleet and its partners around the world. Satellites like the Global Precipitation Measurement Mission provide valuable rainfall data on daily to seasonal timescales for the past 20 years. And it's this information, along with a suite of other data, that go into climate model development.
Currently, GPM micro-imager radiance data are used to generate initial states of NASA climate models and to guide climate model solutions to be close to real states by applying data assimilation techniques.
Data assimilation is the process of combining many different sources of Earth observations into models to improve how we represent the Earth system.
Assimilating GPM microwave imager data improved intensity and locations of storms and precipitation calculated by the climate models.
And once a climate model is developed, it's tested over and over because, well,
all models are wrong, but some models are useful. So they're always going to be incomplete. They're always going to be a not exact representation of the real world. But we want to make sure that they are capturing important aspects of the Earth so that we can treat them as credible going forward.
Typically what happens is when you modify one part of the climate model, other parts accidentally change. It's kind of like the whack-a-mole game. By hitting it down, we're improving it, we're killing the error, we're decreasing the problem existing in the model, but another area pops up.
And that is why NASA observations of the Earth from space, the air, and the ground are critical to understanding how our Earth system works. Observations help improve the modeling for our future here on Earth with new capabilities to expand our knowledge.
NASA is launching satellites and coordinating missions like GPM, giving us that long-term, really accurate satellite record of what's been going on, not just of the temperature rising, but of various aspects of the climate changing. So precipitation and cloud cover and soil moisture and a whole bunch of different climate variables that people care about.
Continuing key observations of the Earth is really important to see how our atmosphere, land, and oceans are changing over time. A long-term record combined with cutting-edge observations from the new NASA Earth System Observatory will continue to push boundaries to better understand our ever-changing Earth.
And I know that was a bit of a long video, but I like to use it to set the stage, particularly when we're looking at climate change, because we're looking at so many variables. And often we're going to hear so much different information about different places. And sometimes it's rather challenging to comprehend. Oh, yes, indeed. Well, I will do that. And everything is also in the, let me see, copy link. Everything is also in the story map. So let me go ahead. I'm going to put the link in there. And I'm sorry about the choppiness. I don't have any other long videos in this. So hopefully we won't have too much choppiness. The other thing I wanted to show you that you'll have here in this resource packet is some more information about these climate models. So here's where you could also see that video, should you want to, or would you like to share it with people? I seem to be muted. Okay, let's figure out what's going on.
I can hear you, Dorian.
Okay.
I was just about to message Richard. I might want to check your microphone,
Okay.
but you're good on, yeah.
I appreciate it. You know how it is. You don't want to just talk into space. So you can come here and you can learn a little bit more about climate models. You can also learn a bit about the difference between weather and climate. Those of you who are working on IVSS projects, it's super important to understand that difference between weather and climate. Weather depends on so many different variables, and weather is kind of like what I'm wearing right now. Right now where I am, it's kind of cold. I've got on long sleeves. I've got the heat on some, and I'm looking out and seeing snow. But next week it's supposed to be warm. So anyway, that's just kind of some neat information to know. I also wanted to show you we have some STEM interviews. Should you have students or be a student who's interested in how did some of these people get into the field of climate modeling? It's a nice opportunity to get a sense and better understand that. And of course, I also put the link here to this campaign to see how we're tying in the satellite mission that I support, the Global Precipitation Measurement Mission, all of NASA's other Earth science missions, and then coming in together, aligning that with the fabulous GLOBE program. It's a real nice and fairly easy alignment there. So let me jump in for a minute and show you the GPM mission. Speaking of alignment, one thing I love about the GPM mission, that it wouldn't come up very big, but is that it is an international constellation. So even though the core observatory, which is what we're seeing here on the screen, is one satellite, it is able to gather data from 9 other satellites, many of which are from other countries around the world. And it takes their data and it's able to run it through its core processor. And in doing that, we're able to get updated precipitation amounts that are falling from the clouds to the ground every 30 minutes for just about anywhere on Earth. And I'm going to demonstrate for you in a little bit here how you can do that for any location, basically taking your last globe observation and looking at your longitude and latitude. So I'll show you that. Let me show you what we have here on board. Basically, we only are using 2 key instruments. We're using our, let me find it here, our GMI, our GPM microwave imager. And that is basically working to, as we fly over the clouds, that's able to see what's inside the clouds, kind of like an X-ray. So it's seeing what kind of precipitation is in the clouds, whether it's snow, sleet, freezing rain, raindrops, the size of the raindrops, and it's able to see what's in there. Then we have our radar, and those radar, when we're flying over with our core observatory, they're able to give us the 3-dimensional picture of how much precipitation is falling through those clouds. So what I hope you kind of take away from that is it's really pretty cool to see what we're able to learn by taking these data from satellites and then taking them to help us better understand what's happening here on Earth. Let me try and show this video. It's much shorter. This does a good job of explaining why we're using satellites when we have other tools here on Earth, as you know, if you do the precipitation protocol, that are giving us precipitation data. So let's take a look at this.
We plan our lives around rain. We always want to know when and where and how much, not just for our weekend plans, but for how we make decisions about our safety and transportation, our economy, or our livelihoods. So How do we measure rain? Well, we can set out a rain gauge, like this one, and it measures the amount of rain that falls over time. The problem with this is that it only measures rain in one very small spot. In fact, if you took all of the rain gauges in the world, packed them together, they would fit into 2 basketball courts. Now, we can cover more ground if we use radar. Radar sends out a signal, and it measures how much of that signal is scattered by rain or snow. But radars are only available in certain parts of the world, and many countries just don't have access to that technology. That's just on land. Think about how we're going to measure rain over all of the world's oceans. Look, the point is it's impossible to cover the entire Earth with enough instruments that are going to give us accurate precipitation rates for the whole globe. So we have to think bigger and higher. Instead of having a patchy network of rain gauges and radars, we could have a whole constellation of satellites looking down at the Earth, measuring things like falling rain, snow, and even ice. The Global Precipitation Measurement Mission, or GPM, is going to do that, and it's going to give us precipitation rates for the whole globe every 3 hours. Now, GPM is going to cover it all, from land and oceans, from the tropics to the edge of the poles, over mountains and valleys, from our farmland to our cities and towns. We're going to need more than a perspective on the ground if we're going to look at precipitation from a truly global standpoint. And GPM is just the mission that's going to give us that big picture.
There we go. So kind of giving us a feel for why we're utilizing this satellite technology. What I do with the GPM mission is I help, as we saw in that video, find ways to take the science and the technology, which is rather complex, and kind of narrate that or translate that so that it makes sense to people who aren't necessarily trained first in science and engineering, but also I work to help people who are doing real world applications. And that's a lot of what our International Virtual Science Symposium questions are. What can we answer using data? What can we better understand? With the GPM mission, we have, that didn't end up coming up very big, but that's fine. We have 6 main pillars showing some of the ways in which our data are being used to make life better for all kinds of different people and even animals around the Earth. Something I really wanted to show you was that you can come into who's using GPM data. You can click on any of these links here, and you can learn about some of the people and how they're using the data to bring about these positive changes all around the world. I think that's always a really neat thing to know. So now let's start to get into how we align this with GLOBE and with the precipitation protocol. So I brought up the precipitation protocol, and basically you have a rain gauge, and I have my rain gauge outside. I've removed my top and my inner funnel right now because we have snow. And that way I look at the liquid equivalent. So you can go on and learn about the precipitation protocol. I want to point out that clouds, which is a super easy protocol you don't need to have a rain gauge for, obviously clouds also tell us something about precipitation. So I'm going to even show you how you can use your smartphone technology and consider doing cloud observations and using those as part of your data, in addition to possibly using GPM data. So let's now look at what the scientists are telling us is the relationship between climate change and precipitation. And I'm going to read this here. This is some information that I got from the Environmental Protection Agency, telling us a little bit about some of the ways in which those climate change models and projections, and also what we're looking at right now as we look at precipitation amounts in different places around the world, what it's telling us. So climate change can affect the intensity and frequency of precipitation. Warmer oceans, they increase the amount of water that can evaporate into the air. When there's more moisture in the air, then, and over land, it can converge into a storm system and it can produce more intense precipitation. Example, heavier rain and snowstorms. And we have certainly seen that where I live in Maryland. I've talked with Yash Raj in India. We often chit chat about the weather and found out that they had absolutely horribly intense rain and hailstorms, and it damaged, severely damaged their onion crop. And their area is known as kind of one of the onion baskets of the world. So obviously, having these changes in precipitation can have a huge impact. Heavy precipitation doesn't necessarily mean the total amount of precipitation at a location has increased, just that the precipitation is occurring in more intense events. So sometimes we see that you'll have certain storms where you have so much precipitation that suddenly you have flooding. Your infrastructure isn't prepared to handle that. That's what's being predicted, is where sometimes we're going to see more intense precipitation falling. However, changes in the intensity of precipitation, when combined with changes in the interval between precipitation events, can lead to changes in overall precipitation totals. The main factors that affect precipitation include prevailing winds, the presence of mountains, and seasons. Prevailing winds are the winds that carry the warm, moist air or cool air over the land. A mountain range in the path of that can influence where the precipitation falls. And I did put this site here. You can go to the EPA site and you can learn more. You can dive in a little bit deeper should you want to better understand this relationship. This is something that scientists are currently studying very carefully. It's not a super easy correlation to say, oh, this is happening and it's going to happen here. That's why having you collect data for your different location and start to look at that data over time is really helpful. And also perhaps you making observations like Grace and I were talking at the beginning of this. I said, here where I live in Maryland, we used to have snow all the time in the winter. And lately, it's been where we went for 2 years with no snow. My 3-year-old grandchildren didn't remember snow from when they were 1 year old. And we had a whole lot of snow last week. Schools were closed. Everybody, most people, not everybody, a lot of people were very, very happy. And children who'd never seen snow before, who didn't remember seeing snow, were able to go out and play in it. So we have questions. We're able to make these observations, but looking at data over time is really going to be helpful to us. So what I want to do is I want to show you how you can collect your data super, super easily. I'm going to walk you through it. I'm also going to show you that you don't need to write down each and every step. Right here in this story map, and I've given you the link, you have information here on how to do this, kind of what I like to call the breadcrumbs or the recipe of how to get in here and do this. I also want to show you something that I just think is super cool. Here is the last, and I'll make this bigger. This is the last week of our precipitation all over the world. So take a look at where you are now and take a look at this precipitation. You want to look at a couple things here. This is, of course, telling you the time and the date, and it's using universal time because we're talking in the language of science. So we're talking about the time that occurs in Greenwich, England, as far as being our time series here. Over here, you can see that wonderful snowstorm that brought snow and joy to the lives of several teachers and children in this area. You can also see, it's a little hard to see down here. It's not showing up super well, but our greens and reds are showing us liquid precipitation. And as you might imagine, when you're looking at our blues up there, that is showing us frozen precipitation. Something I'm also thinking you might have noticed when I told you every 30 minutes we get updated information about how much precipitation is falling. But in the video we watched, it said every 3 hours. And the reason why it's different is because once we got our satellite up and going, a couple of other satellites joined that international constellation. And then that was wonderful because it made it so that we were able to gather more data more quickly. So what I want to show you now is how easy it is for you to just come on in to this site here. It is free to everyone. And I'm going to show you how you can come in here and you can get your data. I'm certainly happy to get it for you if you send me your latitude and longitude. And for that, all you have to do is just do a Globe Observer. Just go out with Globe Observer or with Globe, do a, with your data entry, do any kind of an observation, and it's going to give you your latitude and longitude, and that's all you're going to need. Now, I came here to show you one of the things you're going to want to do with Giovanni is you are going to want to, and I'll put the link right in here because sometimes it can be a little bit of annoying to try to find the link that you want to be looking for. Yeah, Brian, thank you for putting that in there about the what you're seeing in Salisbury, So in order to join Giovanni, it is free. It is a really good idea to join because if you don't, and basically to join, all I mean is you log in and they let you pick a password and you have a login. The reason you want to do that is because then you can look at more data and you can download the data. And when you do join, it's going to ask you some questions, like it's going to say, how are you using this data? Which scientific field are you associated with? Answer the best you can. If it asks, you can put in that you're using it for Globe. No one is going to stop you from using it. They're just collecting metrics to get a feel for who's using this data and why. So don't be afraid if there's some of those questions that you can't answer. Don't worry. They're not looking to qualify you. They're just looking to get some information as you're coming in here. So basically, you will want to register. And of course, you need to, I would imagine that you need to be 13 or older. I'm not positive, but you can take a look here and this will give you that information. Let me see if I can do that. Nope. Okay. So here it knows who I am, mighty convenient. And although sometimes it gets annoying and wants me to be logged in, which I'm not, to my VPN. So I'm going to do it the old fashioned way. Hopefully I remember my information. Okay, try another one. I don't know about y'all, but passwords are the bane of my existence. But I made it work. So I am going to demonstrate for you, and I'm going to show you. Yeah, Grace, thank you so much. The easy breadcrumbs. And like I say, this is all written down too, so you don't have to memorize it. I'm going to come over here and I'm going to say I want a time series reoccurring averages. I'm going to start off over here with seasons. Now you can do days, you'd have a lot, months, seasons, or years. I like to do seasons because that data confesses, and I'm going to show you the difference between that data in a little bit here. It confesses, it tells me a story, but it tells me in a way that is easier for me to comprehend initially. Now I went on and got the longitude and latitude for where the next Globe annual meeting is going to be. So John, this is in your neighborhood here, John Moore. So we're going to be at minus 79.3414. That's going to be our longitude. For whatever reason, you always put longitude in here first. Sometimes we always think latitude, longitude, but I guess they just had to be different. So I just put those coordinates in there because I wanted to get it for a specific location. And then I'm going to come here and we call our data, the data that I'm interested in looking at, iMerge. And I like to work with our most recent version, which is version 7. So again, all that's written down. I want to come down here and I want to get the final run because that's the product that's going to have the most data in it. They have taken not only the data from GPM, but also any other data from these locations that happen to be collected using very standardized technology, and they were able to fuse that into this final product. I want to look at millimeters per month. If I think in inches per month, I could do that. I could do inches per day. In this case, I'm going to look at millimeters per month, and then I'm going to say plot data. So it's going to now be working on plotting that data. I am going to come back over to my story map where I went ahead and I got the data, But then we'll come back over here so I show you how easily this works. Right now, can I get someone to tell me, are you seeing the back to the story map?
Yes.
Okay, cool, awesome. I never know if this works or not. So let's take a peek here. Here we're looking at in Fredonia. They basically never, or it's been since 2001, they have not had no precipitation in a year. Okay, so this scale here, and I think this is super important. Learn to take a look at what these scales are telling you. We're looking at our time down at the bottom. You'll also note, okay, here we go through 2022, and we're looking at amount of precipitation in millimeters per month. So just looking at this, we can see, wow, something happened in 2011. There was a discrepant event. You know, this might be really cool if you're doing your IVSS project and you're looking at precipitation over time. You could take a look back and see, was there an impact on people? Was there flooding? Were there problems with crops? Was there an impact over here in 2011 where there was hardly any precipitation? So that tells us a little bit of the story, but there's still a lot more to understand. Let's look at this one. This one to me gives me a headache, but it's also kind of, it's important. And you can also, we can mess with this data, as I'll show you when we go back to Giovanni. If I look here and I see, wow, there was a lot of precipitation in purple in 2004. I can look over here, okay, that's telling me May of 2004. There was all kinds of precipitation. So basically, we're looking at kind of some spaghetti here thrown on a graph. We're looking at now our data amounts have changed because now we're looking at finer temporal time resolution. So we're saying 25 to 225 millimeters per month falling. And by looking at this, it's just kind of neat because we see, hey, they have a lot of variation in their precipitation. And we can see there's some months where they either have, and years, very, very little precipitation, less than normal, or a lot. So, okay, that's kind of cool. This is the data that I find the most useful when we're looking at doing IVSS projects and when we're kind of trying to get a more general understanding of what's happening. It's also such a neat thing to do, as with the GLOBE program, we're all over the world. How fortunate we are to be able to see. I can look at Yash Raj's data in India for the onion farm that his father owns, and I can see when they have no precipitation at all. And then I can compare and contrast that with where the annual meeting is going to be, where Mike Jabot lives, and take a look here at the variation in precipitation. All right, so here, and for some reason I missed getting, and I'm sorry about that, when I must have done my copy and paste and I missed getting our little link here, but basically we're looking at our key. Summer is green, fall, which is, for us, summer is June, July, August. And this is fall, so this is August, September, October. This here, the black is winter, so this is December, January, February. And that leaves us with spring, and that is the blue color here. So wow, 60 to 180, definitely. And again, for some reason, I cut that data off there, but let's come back over here and see if it's done rendering. All right, this is what we call rendering. So here, the nice thing, and the reason why I wanted to show you this is that you can do a lot when you're using Giovanni. So I can come over here and I can sit on top of any of these dots here, and I can get the specifics on how much precipitation GPM measured falling from the clouds at this exact location in New York. And we can see a lot of different things that this data is confessing to, including a very, very little precipitation, a whole lot less precipitation than they normally get in March, April, and May. And so just there's bunches of things you can do with this. One thing you can do, and this is why it's nice to have an account, is when I come over here to downloads, I could download this in a comma separated values chart so that it's really, really easy. And I'll get the exact numbers to take a look at that in a spreadsheet. Then I'm going to come back over here. I can also, oops, never mind. Let's see if I can get back over to that. Or if it will make me start all over again. And okay. Always a mystery. But the other thing I can do is I can take pictures of it. So I can come over. Let's see here. I just wanted to look at back to my data. Maybe that will tell me, and plot should come up because I've already, oh, well, it's sending me back, maybe. Frustrating when these things, and what I was basically just trying to do is just to go back and show you that there's one other thing you can do with this. And that is once you have your graph up here, you can go over to the far right, and I'll come back to something else and then I'll jump back and show you. And you can save it as kind of like I did here. I cut and paste though here. You can save it as a PDF or a couple of other different ways. Yeah, I'll come back in a minute that you're able to save it. So think about some of the questions that you could answer or that you could look into by having the last 23 years of data. When we're trying to determine climate, we need a 30-year record. Why do we only have 23 years with GPM? Excellent question. GPM, we're celebrating our 10-year anniversary because we launched February 27th. We launched that big core observatory on February 27th of 2014. But we're a follow-up mission to one that launched in 1997 called the Tropical Rainfall Measurement Mission. Even though it launched in 1997, it took a while to ensure that the data we were getting from TRIM was accurate. We had a lot of ground campaigns, and even now it's 2023, we have gone back and looked at that TRIM data and added other data sets as we had them. That's why using this instrumentation, that radar and that microwave, and using that as we fly over, we've been able to go back now. We say we started in about 2000 where we have pretty accurate information. I'm not going to take you through each of these, but I wanted to show you some ways in which you could do IVS projects, SS projects, or that you could even just, not just, but interact, use your data from GPM and take a cloud or a tree observation using Globe Observer or the cloud or tree height protocols. And then you can use that to kind of tell your own story. So as far as kind of say, like thinking of a question that I wanted to answer, and this was a true question for me, my kind of real world question is that my husband and I inherited this lovely little bay cottage. As you can see, it's right, this is our front yard, it's right on the Chesapeake Bay. But the Chesapeake Bay is the area around it is starting to sink. We call that subsidence. And in addition to that, we know that sea level rise is happening. Now, sea level rise, of course, has some relationship to precipitation. It's not exactly a total direct relationship, but that's something you could tease into your project. So something you could do if you wanted to as a part of your IVSS is you could take a look at the amount of precipitation that several of our GLOBE members have shared with us. And you could kind of go around the world and you could see what their water stories are for their locations. And these water stories sometimes are about real world problems like I was coming up with, trying to figure out if we're going to be below water or not. Or my friend over in India with Yashraj, where they have the onion farm and trying to determine what their sustainability is going to be. Some of our GLOBE friends in Oman and Kuwait are telling us about their water stories, trying to access fresh water. And here we do have Fredonia and Mike reporting in on some of the ways in which too much and too little precipitation is impacting them. I was in the Galapagos and I did a story about at Isabella Island where they don't have enough precipitation and some of the strategies that they're using. So just some kind of fun ways you can get in there and mess about. That's still rendering, we'll come back. And then the other one is that you can tell your tree story. So here I was looking at my granddaughter. This was 3 years ago. And I was thinking, here she is by this tree. In 30 years, will that kind of tree still be able to be around based on how climate is going to be changing? So for that one, you can come in and you can pick a tree. You can do a tree height measurement, and then you can send me that data, and I'm happy to get for you your last 23 years of precipitation. Or you can do that yourself now that I've empowered you and given you the tools. And here we have some locations all around the world, and people are telling about their trees. And I'd really, really, really love to populate this. As you can see, some of you were reporting in from places that I do not have yet on this map. And all places are different. So it'd be really, really cool to have different places to add. So with that, I am going to stop. My silly thing is over here still rendering. It's just decided to be obnoxious for me, but get in there, play with it. And if at any time, should anyone have questions about how to use this data, how to interact, with it, what the data is confessing to when you look at your 23 years of data, I am more than happy to assist you with any of that. So I will stop talking now and see if there's questions.
Thanks so much, Dorian. I was starting to check the chat here. Please, if any questions come up, feel free to unmute yourself or put it in the chat here.
All right, I'm seeing Brendan. He's interested how and if the precipitation collected by the GLOBE program. That is a good question, Brendan. Right now, we do have a permanent ground validation facility at Wallops, and I know that they also have GLOBE. They're collecting data for the GLOBE program as well there, as Brian Campbell can attest to. So in that way, you do have kind of ground validation that's occurring utilizing a lot of different resources. As far as having scientists who are working specifically with GLOBE validating or using that as a kind of a ground validation technique, we haven't had that. It really would be kind of a neat thing to do, to take people in different locations, take a look at what their precipitation data says and what the GPM data says. I did that for a little while with the CocoRAS program, and it was really neat to see where they were finding differences. Think about this, and this is one of the reasons why this would be a really neat project to do. It might be pouring rain here at my house, and across the street there might not be precipitation. So it is very possible that your rain gauge in your yard is going to be, well, not possible, it is true that it is going to be more accurate than what we're getting with a satellite that has 10 meter resolution or kilometer resolution, not even 10 meter, versus what you're having at an exact location. So that would be kind of neat. And I'm thinking in a way, Brendan, to do a reverse rather than GPM looking at the GLOBE data. It might be kind of neat for people with GLOBE, look at the GPM data, see if there's discrepancies, and then come up with some reasons why. Why are we seeing these differences? Excellent question. And I'm going to grab the link again and stick the link here because I put in a lot of things so that you can do more research as you are, getting in and interested in this topic. So does GLOBE collaborate with CocoRAS? We sure do. I've gotten to be dear friends with Noah Newman. He's actually going to be presenting in our upcoming 10 in 10 webinar series. So the GPM mission is celebrating the fact that we have been up now for 10 years. And I don't know why I neglected to put that information in, but I'm going to put a link in here. We're going to be hosting a series of 10 in 10 webinars, and these webinars are open to absolutely everyone. We hope that many of you will join us for these, and they will also be recorded. And so during these webinars, where did my thing go? Find another way. During these webinars, we have a lot of different speakers. And because we're trying to pull in a lot of these people who were so incredibly helpful to us and whom we have collaborated with. And Globe program is included as well. They're going to be presenting. So you can please think of joining us. And there you'll also get a feel for what some of that connection is with Coco Roz. They're a absolutely great group. You're welcome. And I hope you will get in there and try to gather your own precipitation data. Then you could also just pick an obscure location somewhere else in the world, or look at, actually don't pick obscure, go and look at our data viz, pick a place that you think, I think I can predict about how much precipitation they have. And it could even be more or less than where I have it. And then take their latitude and longitude, and then put in longitude and latitude in Giovanni, and then see what they have. Or take a look at, or maybe not, and take a look at our telling your tree story, telling your water story, see the variation in amounts of precipitation and get a feel for how that impacts trees and the amount of water that you have in your location. So hope to see some more stories coming through. And you're so welcome. This has been lovely to just hang out with dear friends and family and chat a little bit about what I do. Always a pleasure.
Thank you so much, Dorian. One thing I was thinking about is that first video that you showed, and you kind of highlighted it here, is that how interconnected all of the, it's interconnected of what precipitation is, and it affects our agriculture, it affects our ocean systems. And it's just a really great way to look at lots and lots of different questions and combine also other Globe protocols or other models or data points. So it's just really, really great as a foundation to start telling your water story and connecting it to your tree story. It all allows you to look even more at the climate. And so just really, really appreciate that full interconnection and full scope picture of Earth as a system.
Thank you. And as a system, and also as a system that impacts everything. I'm sitting here with my water bottle, and you can only survive 3 days without water, and that's fresh water. So, what could be more important than precipitation? And just absolutely cool when you stop and think about the impact of precipitation on just about everything. Mosquitoes, everything, that you have in your life. So yeah, our stories are important. Our stories about how we see our climate changing around us, these observations we make, all these are vital. And the data is important, but data without a story behind it is kind of, bland. So by adding your story, you just really you get in there and you massage the data and interact with it. And then you also see, what does that data have to tell me? Like what was happening in Fredonia in that year when they had, so much precipitation, and what is it like, in the time when they have a whole lot little precipitation, or were they not allowed to water their lawns, or, just some of these different things that occur in our life when we have variation in our precipitation. So I look forward to some of your stories, and I look forward to seeing some IVSS reports that are utilizing some of the GPM data as a part of their data. Part of the picture. Yep, we need a lot of different data sets.
Well, thanks again. Oh, sorry, go ahead, Dorian.
No, I just said we need a lot of different data sets to tell a story. Yeah, yep. Definitely.
We definitely do. And I just wanted to thank you again. Thank you for being part of the Year of Climate and Carbon webinar series. I wanted to drop in. If you want to refer back to this webinar, refer back to this recording, it will be on the Year of Climate and Carbon webinar page, where also you can see any upcoming webinars or links to past webinars that we've had. We've had some others about climate modeling. We have some also coming up about some other satellite missions, all to connect what Dorian beautifully said of how you can start creating projects and asking questions. And if you would like to enter them into the IVSS, the International Virtual Science Symposium, or to a local symposium, or a local science fair, or you just want to send us, your, just like Dorian said, your water story or tree story, or, hey, I collected this really cool data point. I want to share it with Globe Science. You want to share it with the Globe Campaigns team. We're always happy to receive those types of messages. It always makes us very, very happy. All right. Well, thank you all so much. We'll stick around for a few more minutes if you have any questions. I'm going to go ahead and stop the recording, however.
So nice to see so many friends. Mwah, family. Greetings. And you are